Hi there, today's tutorial is about should I model the point cloud or should I just take a point cloud section to use it. So the focus is if you are a kitchen designer, interior designer, or someone who builds in things into a building, an existing building, how should you work with the point cloud? Of course, everybody is talking about BIM model and so on, but if we're talking about CAD models, we have straight walls and mostly everything is perfect. In our case, we're using laser scanning to capture the as-built buildings, and we have deviations like the walls are not straight and the ceilings are bended and so on. Let me explain it on a little example. If we look to a regular room, then we have the top view here. Let's say we top view. So we have the room, and then we have our walls like this. And typically, the wall is not perfectly made, so you have a little bit like this. So it's a little round area or an irregular surface. So the architect or the designer, the CAD designer or the CAD drawer who makes the drawing typically use a line or a wall element, and it puts it straight to the points. So you will not have the deviation, and typically in this case here you will have, maybe they do the average, maybe they do the smallest thing, the biggest thing, whatever. You never know what they do and what they model. So, but basically you can see the room is here too big, here too small, and here too big. So that's a big issue for someone who builds in things, because he needs the exact curve of this area. Okay, let's jump to a point cloud. I have my little example here. Let me put this away. And what we're gonna do is we will model an area, the room, and then we do a section through the CAD model. And then the second thing I will do is a point projection. So that's a specific feature from PinPoint, what's very easy. All I'm doing here is PinPoint, and then I will switch over to BricsCAD as a good CAD software or other CAD software on the market. So, but you can do this with your software, what you have already in use. But if you don't have one, then maybe you should look to BricsCAD. I think it's a pretty interesting tool, and especially it's a very interesting deal. Anyway, go back to our PinPoint here. I have a model view. The model view shows you the surfaces of a room and makes the modeling easy. If you open it the first time, it's a little bit uncommon to look to all these different colors, but you will see shortly why it makes a lot of sense. So I go to color, and then I go to regions, and then you see these walls are in one flat surface. So now I will start to model a room. That is, I can switch to English. That may be easier for you guys. Sprache festlegen. English. Okay. Yes. Okay, we are back on now. So you have the same language you see. And I jump back to the room. And here I am, and now I go to add surface. I will model my floor first, so I click on the floor, I hold my floor. That's very easy. So then I have just to add the walls, and it will always create the intersection to the floor. So in the beginning I click this wall and this wall, that gives me the first point, and then I model straight to here. So I pick this wall and this wall, and I have my edge here, and then I can also move the green sphere above two surfaces, and then that capturing or catching directly the edge of the room. And then I go here this way, and going here, and then this edge, and then I have to be careful to pick the right one here, 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 and here, and that's it. So now I got my basic surface. I will use the extrude function to raise the thing to the ceiling, and you see that's fitting perfectly, and that's it. So now I have my first CAD model here, or my 3D model, but because we like to plan a desk or something like this, it's just a sample for you guys. We will do a surface intersection, a model intersection. So I'm using the function surface intersection. I'm picking my floor, and then here's some sockets and outlet. So I will, I know it's, if I type in 0.36, that will be the right position. And I just confirm with return, and I have my CAD file. So now I have my CAD line out of the point cloud, and I can save it. Here's my sketch, so I can save it, and I can say CAD file modeling. Okay, I'll save it. And now I'm doing the other way. The other way will be I do an intersection through the point cloud, so I really get the results from the laser scan. So what I'm doing is I'm using the point projection function. I'm snapping to the floor, and again I type in the height to make the intersection on the right position. But because it's a point cloud intersection, I need a thickness, because if you do like a CAD section with a thickness of 0, then of course you will not be able to catch any point. So what I'm doing is I'm doing 1 centimeter from, for example, from 0.355 to 0.365. So this is 1 centimeter thickness. And I confirm again with return, and it's asking me, should I do an order photo, a 2D line, or 2D points? And I will do the 2D points, and I can reduce them by using here the number, but 5 millimeters okay for now, just for this demonstration. And then okay. And it's creating my point cloud, and of course it's already from all rooms of this object. So, but that's fine for now. So I will save this also, and I will call it point cloud real, and save it again. And now we will jump into BricsCAD software. So I will prepare to import both of these files into the software. That can be also a 2D software, that's fine with PinPoint. And then we talk about the point cloud. So now I'm back in BricsCAD. I imported my 2 floors. You see model and real, like we talked about, and the pink line, I don't know what it is in English. This line is the modeled line, and the other one is from the point cloud. You can see it easily. Let's go to the top view and then zoom in a little bit more to get a better understanding. Let's zoom in here, and you can see actually the points a little bit in front and behind of this line, but you see it's fit very well. It's fitting very well, so that's pretty good. You see here the first deviation. If you remember, these are these areas with the socket and the power outlet. So you will definitely see here, oh, here's something wrong. So if you are in the designing process, you should recognize, oh wow, there's something in front of the wall, or something what's going on. And then of course you can jump back to your project, and you can go to the panoramic view. Actually this is an unstructured point cloud, so I don't have the real images, I just have the texture of it. But I can switch to real true colors, and then I see, yeah, okay, that's my things here. So that's okay, I can live with it, or I have to change my planning, whatever is fitting in your situation. So then I can move on, and I can look here, and yeah, everything is fine. But here you see you have this little thing, and I like to show you a different room. If you look to this room, on the first view it looks pretty cool, but then you see, oh, there's something, here's a jump into here, and there's another jump into here, and yeah, what should I do? And that's what I'm meaning. I mean, if you model the room, you will never catch up these things, because a deviation of 5 millimeters or something will disappear. The model will just straighten up, and that's the way of modeling. Yeah, I mean, a CAD model is always simple to easy geometry that makes the file size so small, and it makes the handling so easy. But in the case of interior planning or room design, sometimes you really need the exact contours to feed your CNC, to make the woodwork or whatever you do, and then it makes sense to extract a point line like this. So, and then let me explain one more thing, because a lot of people are asking about this. If you do this point cloud thing, the point cloud section with PinPoint, and you give it to whatever, BricsCAD, Vectorworks, whatever software is out there, some free software, even LibreCAD, we have some LibreCAD user, it's free CAD software. If you take the line tool and you like to model, most people like to say, yeah, I snap to this point and this point, and what you can see here easily is we are missing the edge. There's not the right point for to model the edge. And this is an important thing you need to understand. If you use a laser scanner, you cannot tell the laser scanner, please measure the exact corner. It will start measuring at some point, and it will end on another point. You cannot say measure from here to here. It's not a total station. Yeah, you have to live with the data like they come from the scanner. In this case, that means you better don't snap to the points. You just go there and you say, the edge will be here. I mean, it's easily to see for the human eye. And then I put my point here, and you see I don't have snapping on. And let's say I make it simple, and I just draw to here. And of course, I didn't import much points. You can have a lot more points and bring in to see more, but mostly it's enough to work with. And then you see here these deviation. You see this wall is even a lot better to demonstrate the thing of this tutorial. And what I'm like to explain is, first of all, you see here's a deviation from the points to the line you have drawn. Use the measure tool to measure the distance from the point to the line to get an understanding how far you are off the line. In many cases, I see people say, oh yeah, we cannot model accurate, blah blah blah, and then they take the measurement and see how much is the distance, and then we're talking about 1-2 millimeters, and they say, yeah, well, that's, I mean, you can spend your time on it if you want. I would say, let's make money and let's earn something here, and so you have to say, okay, that's good enough, move on. And in other case, you can check in your panoramic view, what is it? Is it a picture on the wall, or is it some important thing for utilities or whatever is in the building? And then the last point I like to point out is, you see here, maybe here it's a little bit better to see, you see the variation of these points. It's also very interesting to measure just from this point to this point to get an information how far is the distance between 2 points. Yeah, and in this case I didn't see it, it was 2-3 millimeters. Yeah, that is the noise of the scanner. And then think about your walls. You can measure the noise if the walls are totally flat. In many cases, you have some structure on the wall, and then of course you will see the structure with the scanner. But people coming from tape measure or from disto laser measurement, and they never thought about that the deviation on the wall is now visible. So don't waste too much time on it. So try to be focused, and I think a point cloud section is really a very powerful tool, even if it's just a click or 2 or 3 clicks. It's just defining a surface. Let me show you again. If I jump in, for example, I need an intersection here. I could say point projection starting from this wall, and I like to put in a closet with a deepness of 60 centimeters. I just go pick this wall, and then you see my layer is fitting directly, and I could say, yeah, make it behind this outlet here, from here to here, and then I get my 2D section and I can look to it, and of course I see the whole building. In this case you can use clipping box and so on, but there's a lot of other stuff you can do. Already, that's basically what you can do, and what you have to decide. Should you model your model? If you model, you probably will use the accuracy of your scanner, but you have a clean model. But on the other side, if you do a point cloud section, you will have a very accurate line. And it depends. You can create a point cloud section, you can create a polyline, you can create an autophoto. I prefer the points because the points coming from the scanner, it's unfiltered, it's clearly showing you what's going on. Alrighty, I hope that makes sense for you. If you're not convinced, stay with the tape measure. Have a good day. Bye bye. See you next time.